Hi guys, Dr. Diaz here again. Today we're going to study sigma notation. We're going to read a little bit about this. And look at this example. Suppose that you want to sum the squares of the first 20 positive integers. Okay, well, look what they did here. This actually that we have here is like 1 square plus 2 square plus 3 square, and you know 1 square is equal to 1, 2 squares is equal to 4, 3 squares is equal to 9, and if you keep going all the way up to 20 square, it's equal to 400, and then you add all those numbers. Of course, this looks a little bit tedious to do, and it's actually a long process. So there must be an easy way to add these numbers and do all this process that I'm asking you to do. So let's keep looking. They probably have other ways to solve this one. Okay, look at this one, sigma notation. To reduce the amount of writing, we use the Greek letter, capital letter sigma, this letter here, sigma, and as a symbol of sum and everything of this. In the summation notation as well, here it goes. The summation that it goes I equal to 1 to 20 of I square, it will be 1 square plus 2 square plus 3 square plus all the way up to 20 square. Still, the method is a little bit tedious, and later on we're going to find an easy way to solve this problem. Look, but let's call this thing. Let's name the, well, let's not name, let's look at the name of this index here. This actually is known as the index of summation, and later on you will see that this index of summation is also a dummy variable, because you can change the variable and it only counts as for the numbers you using, tracking the numbers you were counting from, let's say from 1 to 20, from 3 to 17 or something like that. Let's keep going here. Okay, well, another sigma notation. In general, you can write the numbers like A1, A2, A3 as what? The summation of 1 that goes from 1 to n of in, which is going to be I sub 1 plus I sub 2 plus I sub 3 plus, and so on and so forth until you get to I plus n. Oh, here it tells you the definition. Well, not the definition, telling you what is the summation, the dummy variable that I was talking about. You can see some example here. You can use I or J or K and something. It would be useful to use different variables. Well, in advanced math, you will see that there's something needed. Let's look at a simple example. Okay, this one. Oops, I already started writing this down here. The summation that goes from 1 to 8 of 2i plus 1. It's actually this problem. So what I was going to do here is, well, not this one exactly. It is more like this. We're going to do here 2 times 1 plus 1 plus 2 times 2 plus 1 plus 2 times 3 plus 1 plus 2 times 4 plus 1 plus 2 times 5 plus 1 plus 2 times 6 plus 1 plus 2 times 7 plus 1 plus 2 times 8 plus 1. Now look, the first one. 2 times 1 is 2 plus 1 is 3. 2 times 2 is 4 plus 1 is 5. 2 times 3 is 6 plus 1 is 7. Well, you can see you're getting all the odd numbers here. 2 times 4 is 8 plus 1 is 9. 2 times 5 is 10 plus 1 11. 2 times 6 is 12 plus 1 13. 2 times 7 is 14 plus 1 15. And 2 times 8 is 16 plus 1 17. And if you add all these numbers, the answer is going to be 80. Yeah, that's fine. Well, we can do this one. But what if this number instead of 80 is, instead of 8 is 80 or 800 or 8,000? Of course, you're not going to do the sum of those 8,000 numbers or 800 numbers. There must be an easy way to do this problem. And we're going to see this one in a second. So if we move forward here, okay, here's the problem solved. And here's actually another problem we didn't solve, but it's actually, you can try there. It's over in already in the PowerPoint. And that easy way that I was talking about is using one of these equations. which saves a lot of time and time and paper and everything to do this summation. Look at this first one. This first one basically says that the summation of I equals 1 to n of a constant is always going to be the constant times that number m. Like for example, if I give you this one, summation of 1 equal to 1 to 100 of 2, the answer is going to be 100 times 2, or 2 times 100, which is 200. Haha, easy, simple. Right? Let's look at the second one. The second one says the summation of I from I equal to 1 to n is equal to n times n plus 1 divided by 2. Check the textbook, they show you how to get this equation. But I will tell you a little bit of the story of this equation. This equation actually, the legend goes that there was a young kid, I think it probably was in the 1700s or early 1800s. There was this young kid in his class. The teacher, the kids were in the class were driving crazy the teacher, and the teacher was angry and said, "No, everybody has to do homework. Sum all the numbers from 1 to 100." And this little kid raised his hand and says, "I already did." The teacher was mad. "How can you have done that?" I said, "We're going to take your time." "I did here." And actually he showed them this equation. Well, on a version of this equation how to do it. That little kid who was a genius was a famous mathematician, Carl Friedrich Gauss. And he did it when he was a kid. Grammar school. Well, that's how the legend goes. And actually he did a lot of contributions in math and science and physics also. And I'm sure some of you heard in statistics, the Gaussian and all kind of stuff. Oh, wait, we go back. Okay, so and here's for I squared, which is actually another useful equation. Let's do one example with this one so you see how it works. Let's go. Oh, but before doing this example, look at this one. This actually is a very convenient way to solve the problem. It says here, when you have a summation of, let's say, a function with different terms, it would be easy to do the summation of each of these terms instead of doing like everything under the parentheses. Yeah, that saves you time too, because then you work on this one and work on this one individually, and you apply the equation that you need, and voila, you get the problem solved. And also, look here, this one is telling you that you can take outside a constant and still solve the problem. So let's see this one in a second how it works. Alright, you remember the problem we did a moment ago? Here it is. So let's try to do this one. This one would be the summation of, let me do it individually now, of 2i, there goes I equal to 1 to 8, plus, because now I'm separating these two, the summation of I that goes to 1 to 8 of 1. Right? This actually we're doing this one. So now we're doing two different summations. Two different summation for 2i and for 1. We did it here individually because it's going to be easy for us to solve it. This one is going to be, we can take the 2 as a constant outside the summation of I plus, and now look what we're going to do here. If you remember one of the rules a moment ago, this is a constant. The only thing you have to do is multiply by this n number, which in this case is 8, and you get already this one solved. So this one solved is going to be what? 8 times 1, which is 8. Now this one, how we solve this one? This one is going to be what? 2 times, now using the equation, and I'm going to write it here a second, the one that says summation of I equal to 1 to n of I, this is equal to what? n plus 1 divided by 2. So in this case, n is 8. So it's going to be 8 plus 1 divided by 2 times 8 times 1, which is already 8, right? We already solved this one. Now look at this one. You can cancel here the 2 and 2, and you got a 8 times 9, because 8 plus 1 is 9. This is going to be 72 plus 8. This is equal to 80, which is the answer we did when we got when we did the problem the long way. Cool. Now let's see if we can apply the same thing for this number here, for the one that it says 800. Oh, look here. They did actually here, this problem. Look, they do the same thing. They have the summation. They're going to do it individually. And now they apply the formula, the n.